Hello children, welcome to Math Park. In our park, today we are going to learn cubes and cube roots for class 8. Now what are cubes? When the number is multiplied to itself thrice, what we get is called a cube. And we have learned in the laws of exponents, when 2 is multiplied 3 times, we write it as 2 to the power 3. We read it as 2 cube. So when the number is multiplied thrice, what we get is called a cube. Now here are the cubes of numbers from 1 to 10. Important children, to know the properties of cubes and cube roots, you have to learn at least the cubes of 10 numbers, first 10 numbers. So cube of 1 is 1, cube of 2 is 8, cube of 4 is 64, cube of 5 is 125, cube of 6 is 216, cube of 7 is 343, cube of 8 is 512, cube of 9 is 729 and cube of 10 is 1000. Now what do you observe here? Look at the odd numbers. The cube of odd numbers are odd. Cube of 1, 1. 3 and 7 are odd. 5 and 125 are odd. 7 and 343 odd. 9 and 729 odd. And cube of all even numbers. Cube of 2 is 8, which is even. 4 and 64 even. 6 and 216 even. 8 and 512 even. 10 and 1000 even. So the first property, children, the cube of odd numbers are odd. The cube of odd numbers are odd. And the cubes of even numbers are even. The two properties clear, children? So what we have seen, cubes of odd numbers are odd. Cubes of even numbers are even. Another important thing, can you see, purposely I have written the cube of 2 and 8 with red. So cube of 2, it's ending with 8. And cube of 8 is ending with 2. So a reverse thing is happening for 2 and 8, remember. And cube of 3 is ending with 7. That means the unit digit of the cube of 3 is 7. The unit digit of the cube of 7 is 3. So there is an exchange for 2 and 8 and 3 and 7. And for rest it remains same. You know, the numbers are ending with 0, 9, 6, 5, 4 and 1. The cubes are also ending with the same numbers, same digits. Is that clear, children? Okay, so this was about the properties of cubes. Children, let us understand why should we study cubes and cube roots. So what you can see here, it is a cube which you like to play with, right? And all the edges are of same height. This is a 3 by 3 cube. This is 2 by 2 cube. Now, if you are asked how much space of this room does this cube occupy? So there you need to find the volume of a cube. So volume of a cube is length multiplied by length multiplied by length. All the three, length into breadth into height, all of them are same. So this application of finding the cube and cube roots you are going to need when you are going to learn the topic of areas and volumes further. Okay. So now let us start with the questions based on cubes and cube roots. Our first question is, show that 9261 is a perfect cube. Now to show this 9261 is a perfect cube, we start doing the prime factorization of a number 9261. Now since it is odd, we can see the divisibility rule here. 6 plus 1, 7, 7 plus 2, 9, 9 plus 9, 18. So this number is divisible by 3. So we start dividing this by 3. When you divide by 3, you get 3087. If you are not able to do it orally, children, you can do in the rough work. Again, we can divide this number by 3. 3 ones are 3. 0, 3. You get 1029. And 1029, when again you divide by 3, you get 3 3s are 9, 3 4s are 12 and 3 3s are 9 again, 343. Now 343, just now when we were looking for the cubes, we know it is a cube of 7. So I know it is divisible by 7. On dividing by 7, I get 49. Again 49 is divisible by 7. I get 7 7s are 49 and 7 1s are 7. So observe, children, here whenever the number is a perfect cube, the primes will always occur in groups of 3. The primes will always occur in groups of 3. Right? So this is how whenever the primes are occurring in groups of 3, we can say that 9261 is a perfect cube. And to find the cube root of that number, so this is the symbol for finding the cube root. Cube root of 9261 when I have to find the cube root of this number, what do I have to do is, I have to simply take 1 out of this group. So 1 from this group, 1 from this triplet. So 3 into 7, I get the cube root of 9261 as 3 sevens are 21. Understood, children? So to show that 9261 is a perfect cube, what did we do? We did the prime factorization of a number. We obtained that the primes were always occurring in a triplet. They were occurring in a groups of 3. Whenever the primes are occurring in a groups of 3, we say that the given number is a perfect cube. Now the second question we will check, show that 384 is not a perfect cube. Now we have seen when it was a perfect cube, the primes were occurring in a groups of 3. So let us check what happens when we find the prime factorization of 384. So to find the prime factorization of 384, since it is even divisible by 2, so dividing by 2 I get 192. It is easy to divide by 2, children, just do half of that. 192, again I divide by 2, I get 96. 96 I divide by 2, I get 48. 48 divided by 2, I get 24. 24 divided by 2, I get 12. 12 divided by 2, it is 6. And 6 divided by 2, I get 3. And 3 divided by 3, I get 1. Now what are we seeing here? Look at this. 2, 2, 2. I found a triplet here. Again 2, 2 and 2, I found a triplet here. Okay, but this 2 and this 3 need 2 more 2s and 2 more 3s to form a triplet. So this is why we can say that since the primes do not occur, since the primes do not occur in triplet, 384 is not a perfect cube. Got it, children? So to decide whether it is a perfect cube, we have to find the prime factorization. To decide whether it is not a perfect cube, also we have to find the prime factorization. So if the triplets, the prime factorization do not occur in a triplet, then we say that the given number is not a perfect cube. Understood? The typical question asked, find the cube root by prime factorization. Okay, or for the same question it can be asked, show that 46,656 is a perfect cube. So for that, what we have to do again? Do the prime factorization. Since it is an even number, we start dividing by 2. It's easy. 2 2s are 4, 2 3s are 6, 2 3s are 6, again 2 2s are 4, remainder is 1, 6 16, so 2 8s are 16. Again it is an even number, so we divide by 2. On dividing this number by 2, children, I am getting 1 1 6 6 4. You can try this in the rough if you are not able to do orally. Again it's an even number, we divide by 2. I get 5 8 3 2. Again dividing by 2, I am getting 2 9 1 6. Again dividing the number 2916 by 2, I am getting 1 4 5 8. Dividing this by 2, I am getting 729. We have already seen that 729 is a cube of 9. So now it is divisible by 3. Since we are talking of prime factorization, 9 is not a prime number, so we divide it by 3. So dividing by 3, I get 243. 243, again I divide by 3, I get 81. 81 divided by 3 is 27. 27 divided by 3 is 9. And 9 divided by 3 is 3. 3 divided by 3 is 1. So what did we obtain here? Look at this. Are we getting a triplet? Yes. 1, 2 and 3. We can see that the primes are occurring in the groups of 3. So definitely 4 6 6 5 6 is a perfect cube. Now to find the cube root of a number, this is the symbol to write the cube root, children. Cube root of 46,656. Out of this, each of the groups will just lift 1. So from here 1 2, from here we take 1 2, from here we take 1 3, and from here we take 1 3. So 2 2s are 4, 4 3s are 12, 12 3s are 36. So this is how we get the cube root of 46,656 as 36. Understood, children? Did you understand the prime factorization? If you don't understand how to divide it orally, this will come after practice only. If you are not understanding how to divide orally, do it in the rough and do the prime factorization. Don't get scared of a big number. It's easy. The next question is, by which smallest number should 648 be multiplied to obtain a perfect cube? Now we have seen the perfect cube should have the primes in a group of 3. So again we start the prime factorization of 648. Even number, so we start dividing by 2. Dividing by 2, I get 324. 324 dividing by 2, I get 162. 162 dividing by 3, I get 81. Sorry, 162 dividing by 2, because it's even, I get 81. And now 81 I can divide by 3, so I get 27. 27 divided by 3, I get 9. And 9 can be divided by 3, so I get 3 3s are 9 and 3 1s are 3. Now children, what is happening here? Can you see this is having a triplet? This is a triplet, but this 3 is left. It needs 2 more friends. So what should be done? What is the smallest number? Should be 648 be multiplied to obtain a perfect cube. So I have to have 2 more 3s over here. Okay, so look, 648 divided by 2, I got 324. 324 divided by 2, I got 162. And completing the prime factorization, the 3 is left alone. So I'll need 2 more 3s to form 1 more triplet. So the number by which, the smallest number by which 648 should be multiplied is 3 and 3. So the number we need is 2 more 3s. 3 3s are 9. So we multiply 648 by 9. 9 8s are 72. 7 carry. 9 4s are 36. And 36 plus 7. 36 plus 7 is 43. 3 4 carry. 9 6 are 54. 54 plus 4 is 58. So 5832 is the perfect cube. And if you have to find the cube root of 5832 children, you don't have to do the prime factorization again. You are going to have 2 more 3s if I am going to take this number. So just take 1 out of each group. So you get 2 into this one, 3 and 1 more, because you have multiplied by 9. So again you are going to get a triplet into 3. So you get 2 3s are 6 and 6 3s are 18. 2 3s are 6 and 6 3s are 18. So 18 is the cube root of 5832. Understood? So smallest number to be multiplied. So it has to be a triplet. So 2 more 3s were required. 2 more 3s means 3 into 3. 9 is the smallest number by which you need to multiply to obtain a perfect cube. Understood? By which smallest number should 704 be divided to obtain a perfect cube? Find the cube root of the number so obtain. So again we start the prime factorization of 704. It is an even number, so we start dividing by 2. Dividing 704 by 2, I get 352. 352 again dividing by 2, I get 176. 176 I divide by 2, I get 88. 88 divided by 2, I get 44. 44 divided by 2, I get 22. 22 divided by 2, I get 11. And 11 is a prime number which can be divisible by 11 only. So now when we look at, we have a triplet. This is having a triplet. There is one more triplet. And 11 is the prime which is left alone. So let us get rid of. So if I remove this 11, then the number which is left is definitely going to be a perfect cube. So smallest number to be divided is going to be 11. So 704, if I divide by 11, what I get is going to be a perfect cube. And how do I orally divide it? Just multiply this. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. Easy. So the smallest number required was 11, and find the cube root of number so obtain. So cube root of 64 is nothing but 2 from here and 2 from this group, which is equal to 4. Understood children? So we have seen by which smallest number should we divide 704 to obtain a perfect cube. We found the prime factorization. 11 was left alone. Okay, so we want to get rid of 11. So we divided by 11. We got 64, and 64 is a perfect cube and it is a cube of 4. To obtain the cube root, we just take 1 out of each triplet and we find it. Next question, children. By which smallest number should 42,592 be divided so that the quotient is a perfect cube? Again, we do the prime factorization of this number. Do not get scared if the number is big. Slowly start dividing. 5, 2, 4, 2, 5, 9, 2. I start dividing by 2 since it is even. On dividing by 2, I get 2, 1, 2, 9, 6. Again, I am telling you, if you are not able to do orally, this will come only after practice. You will have to divide in rough. Dividing by 2, I get 1, 0, 6, 4, 8. Again, dividing by 2, I get 5, 3, 2, 4. 5, 3, 2, 4. Dividing by 2, I get 2, 6, 6, 2. Again, dividing by 2, I'll get 2 1s are 2, 2 3s are 2 3s are 6, 1 3 3 1. Now 1 3 3 1 is divisible by 11. So I divide by 11, I get 121. 121 dividing by 11, I get 11. And then 11 1s are 11. So what do you obtain here? We are getting a triplet of 2. We are getting a triplet for 11. But this 2 needs one more in its team to form a triplet, right? So, and it is to be divided. 4, 2, 5, 9, 2 is to be divided so that the quotient is a perfect cube. So, we can see that there is a triplet. There is a triplet for 11, but bechara 2. It needs one more 2, right? But here we are asked the smallest number to be divided, right? So we have to, instead of obtaining more, we have to divide. So I want to get rid of this 2 and 2. So 2 into 2 is 4. The smallest number to be divided by 4, 2, 5, 9, 2 to obtain a perfect cube is going to be 4. The smallest number is going to be this 2 into 2, which is 4. On dividing by 4, what are we going to get is just look at this. Find the product of this 2. 8 into 1331, which you get as 10648. This is a perfect cube. And to obtain the perfect cube of 10,648, just we take 1 out of this triplet of 2 and 1 out of this triplet of 11, and we get it as 2 into 11. 22 is the cube root of 10,648. So children, did you understand the smallest number to be divided, smallest number to be multiplied? The basic principle here is prime factorization. Okay children, please practice several sums. With the practice only it will be easy. The next question is estimate the cube root of 9197. So we are just guessing. So this may not be a perfect cube. So what we do is, just before that, closer to that, we know that 8000 is a perfect cube, right? And the cube root of 8000 is going to be 20. And just now in this video itself, before we have solved, the cube root of 9261 was 21. Now this number 9197 is lying between 9261 and 8000, correct? So the cube root of this number is definitely going to lie somewhere between 20 and 21. So we just estimate the cube root of 9197. It could be 20.8 or 20.9. So we write it approximately. So cube root of 9197 is approximately 20.9. Now if you have to guess a cube root of 4913, look at the unit digit. The unit digit here is 3. So unit digit of a cube root is going to be 7. So we take this pair. So the number left is going to be 4. And less than 4, the perfect cube is 1. So it could be 17. So we estimate the cube root of 4913 as 17. Children, understood the concepts, all of you? Do watch again if not understood. And if you like it, do not forget to share with all your friends. Thank you for watching. Subscribe if you have not.